So what is closure in JavaScript? Closure in JavaScript is a function that retains access to its outer scope even after the function is executed. So basically what closure means is, like, suppose we have an outer function and it has a variable count. What happens is, like, when we define another function inside that outer function, the another function also has the access to that same variable. This is typically useful when we start returning function from outer function, and it kinds of help us to get a private variable kind of thing. Let's see it in action here. So here what we are doing is, like, this is the outer function and we are returning an inner function from that. So what interesting here is that from the inner function we can access like the outer count variable. From the inner function we can change the count to, or basically add any logic based on the count variable. But how does it happen, right? How does it happen? That's an interesting question. So it happens because JavaScript is basically lexically scope. Now you will think, like, what is lexically scoping means? So lexical scoping means that a function scope means that where it can access variables, right, is determined by the function where it is written and not where the function is called. So that's why inner function has access to count even after outer function execution. But what's opposite to lexical scoping? Dynamic scoping. Dynamic scoping, which means the function scope is determined by the context in which it is called, means the call stack and the runtime environment. So here we have two runtime basically, and this one is like a dynamic scoping and this one is like lexical scoping. Like, this is a hypothetical language basically. So here we are simulating the dynamic scoping. So here we have a variable x in the outer scope, basically the global scope here, and we have a function outer and then we have function inner. When we call outer, what do you think will be logged here? What the x value will be there? So basically when we call outer, then the inner will have the x value of 10 basically. Now you will be wondering why 10, because it's dynamic scoping and outer is being called in the global scope. So in global scope it refers to the x with the 10 value. Now this is lexical scoping, an outer, and then we have an inner, and here we have x equal to 10 in global. Okay, now when we call that inner, so the x value will be here refer to the x20 from the outer function. X will be equal to 20. This happens because doesn't matter it's in global or anywhere, basically due to lexical scoping it will always be referred to x from the outer and not from the global scope, right? Now let's take a very simple example. Suppose we are developing a game, and a game where the player has a total of 3 lives. Now we want to write a function named death, which when called reduce the player's life. And you will say it's very easy. What we develop is to keep a global variable, but there can be many players and we need encapsulation for all. So we'll be basically polluting global scope. That's not a good solution. So what do we have? We have closures here. So here we have defined a handle death function, and it has a argument of lives, and the same lives is being referred from the inner function. In the inner function we have some logic here which checks the lives being passed, and it reduces the life. So here when we create a handle death with 3 lives, so here we will call, so the life will be equal to 2. Then when we call, the lives will be equal to basically null or 0, whatever the implementation is. So what it's offering is we can create multiple kinds of someone with 5 lives. We can pass 5 here, 10 here, whatever, and we can call the death function based on that. Okay, so this is a code example here. So it's taking life here, okay, and it's checking if life is greater than 0, we have to reduce the life, and if life is already 0, we'll return game over. And then here we can see the console. Now let's get to some practical use cases. So the first is data privacy. Okay, so suppose we are designing a user bank account, and user have balance. So the balance can only be changed. Someone calls a withdrawal function or someone calls a deposit function. There is no other way you can access the balance from outside scope. Then we have event handlers. So when we assign some event handlers in our JavaScript, so due to closure only, the event handler remember the state at the time event handler is assigned. So we know whatever the value is being passed to them. And we have callback functions which like retain necessary context for asynchronous operation, usually in like fetch and all that. And that's also the cause of closure. Then we have like memoization. We can like allow storing result for expensive computation, very common use case. Here we also use closure. Then we have like partial application. Partial application is like, suppose we want to create greet. It will take a language and then it will return a greet function. It will take a name. So now like with this we can create multiple greet function for several language. What closure is doing here is closure is passing hello for all the language passed. So basically like it's filling some details beforehand. That's it for the closure today. Okay, bye.